Proving trig identities. Kentucky State Standard. Proving identities and formulas within the context of trigonometry. Excuse me. Previous knowledge. Identities. So we've previously seen the reciprocal identities. Sine of theta is equivalent to 1 over cosecant. Likewise, cosecant is equivalent to 1 over sine. Cosine is equivalent to 1 over secant, and secant is equivalent to 1 over cosine. Tangent is equivalent to 1 over cotangent, and cotangent is equivalent to 1 over tangent. The quotient identities is the tangent of theta is equivalent to sine over cosine, and cotangent of theta is equivalent to cosine of theta over sine of theta. Pythagorean identities is sine squared plus cosine squared equals 1, and you can divide each of those by cosine squared and obtain tangent squared plus 1 equals secant squared, or divide everything by sine squared and get cotangent squared plus 1 equals cosecant squared. We have previously used these identities to solve trig problems with numbers. We're now going to use it to prove identities. It's first important to look at many of the guidelines that we will use in order to prove these identities. The reason why we go through proving identities is the more comfortable you become with manipulating the different identities, the easier it will be when we start solving equations and using many of the other identities such as sum and difference, double and half angles. So you need to get comfortable with looking for certain patterns and certain relationships. So, step 1, pick one side of the equation to work with. Usually it is easier to start with the more complicated side. 2, never work across the equal sign. This assumes equality, and equality is what you're trying to prove. So you cannot add a number to both sides. You cannot multiply a value to both sides. You can't square both sides. Those type of behaviors assume that the two sides are equal. We're trying to show they're equal. So we're going to choose one side and work on it alone. Number 3, change every expression to be in terms of sine and cosine. So if you have nothing else that you can think of to do, just change everything to sine and cosine and start manipulating there. 4, look for algebraic operations you can perform, such as factoring, finding a common denominator, multiplying by a clever form of 1, because remember you can multiply by 1 and not change the value, multiply by conjugates, which is another way of multiplying by a form of 1, distribute terms. 5, look for trig identities, those identities that we just looked at. If you have a 1 or squared functions, focus on the Pythagorean identities. Often the reason why you multiply by conjugates is to create those Pythagorean identities. 6, keep looking at the answer. That is your goal. Keep your eye on the prize, so to speak. Kind of know what you're trying to get to. It might help you make decisions on what you should try. Number 7, remember, there will be more than one way to solve an identity or to verify an identity. So don't quit. If something doesn't work, sometimes you just need to stop and try something new. And number 8, when you're finished, put QED at the end. It is a Latin phrase which means which was to be demonstrated. Often at the end of proofs, mathematicians will write QED. So, even though you are not allowed to cross the equal sign when you are verifying an identity, these Pythagorean identities have been proven. They're given to you as true. So remember, you can manipulate them. So I've showed you several different manipulations of the standard identity here. I didn't show you all of them. Obviously, you could see on the second column, third row, I have a tangent squared minus secant squared equal to -1. You can also multiply everything by -1 and have that equal to a +1. So these are just different variations of the original Pythagorean identity that you can manipulate in order to help you prove the identity. Also, mindset. Some people get very frustrated with identities. Try to look at them as puzzles that you're solving. You know the answer. It's how do you get there? And this is a good way to help you think logically, help you understand why you do something. So as we work through these problems, we're going to talk about why we can do each step to help you get into that mathematical mindset. So example 1, we're going to prove the identity 1 over cosine squared beta minus 1 is equal to tangent squared beta. Now we're going to focus on the left-hand side. In my opinion, it's more complicated. So what we're going to do is we're going to first apply, wrong direction. We're going to first apply the fact that 1 over cosecant squared is equivalent to secant squared. Remember, that is what we call the reciprocal identity. Then, secant squared beta minus 1 is equivalent to tangent squared. That's the Pythagorean identity. And you can see tangent squared is equal to tangent squared. So you've completed that proof. We never touched the right-hand side. We never did anything with the tangent squared. We just took the left-hand side and applied those identities until we made it look like the right-hand side. Let's look at another one. Example 2. Tangent x plus cotangent x equals secant x times cosecant x. Now in this case, we're going to focus on the side with the plus sign. Often addition is more difficult than multiplication, so more complicated. And we're going to start by writing it in terms of sines and cosines. That is not the only way you could solve this problem. It is just the method I chose. So you can see tangent is equivalent to sine over cosine, and cotangent is equivalent to cosine over sine. That's based off of writing in terms of sine and cosine and using your quotient identities. We can now find a common denominator by multiplying the first fraction by cosine over cosine, or sine over sine, and the second fraction by cosine over cosine. That yields sine squared plus cosine squared over cosine x sine of x. Now you'll see the numerator is a Pythagorean identity and is equivalent to 1. Sine squared plus cosine squared equals 1. So it helps to get used to looking at those identities. And then, remember, keep your eye on the prize. We're looking for secant and cosecant. Well, based off of the reciprocal identities, we know that 1 over cosine is secant and 1 over sine is cosecant. So now the left-hand side is equivalent to the right-hand side based off the reciprocal identities, QED. We have completed that proof. Now, I know I went through that rather quickly. I apologize. I'll try to slow down on the next one. And we'll think through it and go slow. So here's our identity. Sine squared times cosine times secant is equal to 1 minus cosine squared. Now this one's tough to kind of decide which side's more complicated, but because we have 3 functions on the left-hand side, let's focus there. First thing I'm going to do is I'm going to write secant as 1 over cosine, applying the reciprocal identity. Now, you can also think of this as we wrote everything in terms of sines and cosines. You have cosine times 1 over cosine, that's equivalent to 1. And if you multiply by a form of 1, you're using not only the multiplicative inverse, but the multiplicative identity. So that leaves us sine squared equals 1 minus cosine squared. So we know, based off those identities I gave you in the beginning, that we can also write sine squared as 1 minus cosine squared, because we can manipulate the Pythagorean identities, QED, because we now have the two sides equivalent. Now, the more of these you do, the better you'll get at these. It does take some practice and trial and error. Let's look at example 4. This one's tough. It starts out with cosine alpha over 1 minus sine of alpha equals 1 plus sine of alpha over cosine of alpha. So they're very similar. So really, whatever side you work is up to you. Now they're already in terms of sine and cosine, so there's nothing for us to do there. There's nothing to factor. There's no common denominator. So we're going to try one of those clever forms of 1, and we're going to multiply by the conjugate. So I chose the left-hand side. You just as well could have chosen the right-hand side, and I multiplied by 1 plus sine over 1 plus sine. And I did that because when we multiply the denominator out, you'll see that I get 1 minus sine squared, because remember they're conjugates, and that leaves you 1 minus sine squared. Now notice I didn't distribute my cosine on top. That's because ultimately I know that I want a 1 plus sine left on top. Keep your eye on the prize. Keep focused on the side of the equation so that you know what you need. Now the only thing we did here, the reason was simplifying. We just multiplied everything out. So now the next thing we're going to do is we see this 1 minus sine squared down here. That is equivalent to cosine squared. And that's because of the Pythagorean identity. Now you can see that you have a cosine on top and a cosine on bottom. Which will cancel, leaving you 1 plus sine over cosine. And that's just because we simplified, and you have completed that proof by canceling those two out.